Okay, let's go. So we're web developers. A lot of people are web developers, and I just want to take a tour and look at some of the sort of fundamental tools for trade, TCP, IP, and HTTP, and we'll get to some F# at the end there as well. So there's a reason why we're at the F# meetup, kinda. So I want to look at a little bit. We're going to start with the basic TCP IP thing. And work us up from there. So I'm going to be a server now and just listen to localhost port 9998. There's a reason we're two, because TCP IP is boring if you're just one person. You need to be like two. There's two parties involved there. So I'll listen here, and then someone can connect. I just listen for someone. I wait for someone to come and talk to me. I don't know, maybe there's someone here. So, hello. Yeah, I can answer. Okay, fine. Hi, who's there? And this netcat is a TCP IP tool that it automatically makes the binary stream into text, and it's line-based. So every time you type enter, it will serialize the text and send it to the other end, right? So TCP IP is a binary stream both ways, but we have text now. I'm Sigurd. Hi, Sigurd. Nice to meet you. So we can continue like this for a while, but it gets a bit dull, I guess. Okay. I can hang up. I do Control D, end of file on my side. I guess you can do Control D on your side if you like, or then we send end of file and we hang up, and the conversation is over. I can, if I want to, I can do like look netstat. I can look at what's happening, so I can listen. I can see this connection here, that there's someone now listening here, and this socket here is in time wait. We can come back to that later, perhaps. If Sigurd connects to me again, when I look at this, I can probably see the connection here that it's established. So this is me at localhost 9998. This is Sigurd at localhost and some random outgoing port. And that is really takes us to the domain model. Everybody who's read Scott Blashin's books on domain modeling in F# knows that almost all domain modeling should be done in F#. I managed to sneak in a little bit more, yeah. So there's a type, a socket. Sigurd is a socket, and I'm a socket in this case. I guess like when we connect, right? So it's one IP address and one port. Sigurd, I guess, was, yeah.
I had a port, very high port, random port. That was my source. When he sends packets to me, it's on that high number port. And when I send packets, I'm sending packets to him, I'm sending it to this low port number 9998, because that's what's announced.
So a connection. So there's one IP address and one port. That's a socket. You take two of these sockets, you have a connection. So one example, if we're going to instantiate this domain model, it's these two. Well, if we're going to be very accurate, it's this number. I guess I can run it as well, so we can have a look at it. It's a very dynamic domain model here. So a connection is then these two sockets, and that's really it.
But the connection is two-way, because neither of us, after connection, is the server or the client. We have established a two-way communication. So
yeah,
I can send a message to you whenever I want, and you can answer it whenever you want.
Yes, so that's a very good point. Like only in the establishing of this thing, when I'm listening and you're connecting, we have like a client-server relationship. The way I understand it anyway is that once we have established, we're mutuals. Both can hang up, both can send data back and forth. There's no server and client anymore. Let's see if I can. I have a machine running in the cloud here. This is really my daughter's Minecraft server, and she shows the password, and I was teaching her strong passwords. So just bear with me while I something with Pokemons. You won't guess it anyway. This server is on the is on the internet. If it's listening on this IP and this port. Now this is in Azure. It's mapped to an external IP which has a domain name, so it's possible to talk to this as well. So I was listening at port 1305. Then I can go talk to this machine on the internet. And you can as well if you connect to it, if you have netcat or something. Yeah, or if you point a browser to it. But we can come back to that. So this works really well over the internet. That's how everything we build works, right? But it gets a bit tedious. This protocol, it has a little, doesn't have a lot of, sorry, no. So if I listen again.
And I do a curl. So the web client on the curl localhost HTTP, right?
HTTP and then port 998. So now he's going to talk HTTP because curl is an HTTP client, so we're adding some more formality to it. I'm still. Yeah, and yeah. And I'm listening, so okay. Sigurd is talking a lot more. I can't try to say hi just to demonstrate it first. That didn't Sigurd like very much, did it?
So, but what you see on his end is that I've sent 4 lines of text. I sent get and the root of the domain because I wanted the root of the domain. And I'm sending hosts. I'm expecting to talk to localhost at this port. And I'm a user agent, curl, and I accept anything you'll send me.
Yeah. Yeah, anything conforming to the HTTP protocol. So now I need to talk to HTTP protocol. I can say 200 OK, content type, plain text. I do 2 line shifts to say, okay, I'm done with all the headers. Now I can say, hey, who are you? Again, and I do Control D to end of file. Oh, and that goes through. Yeah. Now, who are you? Now you can't reply anymore.
so the conversation is over.
That was boring.
But that's the basics of HTTP. It's just text documents that's sent over the wire.
Yeah.
But I can also start browser on this
okay,
to this machine. So so artisanal this domain is resolved to localhost, so it should work.
Yeah, there's a problem by that. You should better use localhost because there's something it thinks it's on HTTPS now.
Yes.
So if you do localhost instead. So we're still only talking HTTP, plain text, no security in the protocol layer yet. Okay, so if you're a browser, I think local, I can do. There's something with the loopback adapter, so sometimes they work. Yeah. So now he's talking to me. He's very verbose. There's a lot of stuff in here. But I can try to answer you. I can send HTTP back. I can send text HTML. I can send some HTML. See if you can see the browser at the same time. It's a little bit more interesting. There's not a lot you can do right now, is there? You're sort of just HTML. Hi, Sigurd. I don't know that it's Sigurd. I can say hi. Should say hi. Yeah. I can send them images. That's what HTTP really is for, isn't it? Sending some images. Didn't want to display it because it was over HTTP. We can come back to that later. I could ask who Sigurd is, so I can send him like a form. And now I can ask what his name is. Sigurd. Now a nice name of talking to him and prompting me with proper input and so on. The problem now is that this thing now is sort of sending this data back on another connection, and this netcat thing here is what we call iterative server. So it accepts one connection and then it blocks and it waits for the next one. So if I quit this and I listen again, maybe the browser will like I have to be really fast, and probably it's not, you need a concurrent server that can handle many clients at the same time, right? And that's when I thought, oh, I really need a concurrent server where I can type by hand, and I couldn't find one. So I thought maybe I need a change to my domain model. So I say what I need is not one connection. I need type connections, which is a connection list. I need to be able to handle that. And then, of course, you pick up your favorite programming language, Sharp, and we can come back to the implementation maybe later. And then I can start my chatbot, which is a concurrent HTTP server, but for answering by hand. This is my artisanal web server for uniquely handcrafted HTTP. And I guess we don't need two anymore because we have this one. So now nå kan du bruke yeah. So this one supports SSL, so he can talk properly, understand the domain name. There's two connections. You're very eager to talk to me. So yeah, he has like a backup channel here, I guess. So I can send the response we tried the last time. Just paste. Oops. Copy. Paste it in here. What? What's wrong with copy paste today? Copy paste. That's a bit weird. I can type. So I can send this form again. Really would like to be able to copy paste this. The problem is that it's, what I'm gonna do? I'm gonna do a little bit. This was running in VSL in Linux GUI, so I'll rather run it, I think, on Windows. I think it's going to be a little bit easier.
Copy paste buffers are the same on the same OS.
Yeah, because I was copy pasting between OSs, I think that might be a bit weird. So this application is in .NET, and .NET now is of course multi-platform, so it works on all, it works on Windows, it works on Linux. So we can, I guess, just try again, fire up the request. It comes in here. Hopefully now we have copy paste. That would be really nice. Yeah, we have copy paste. So now I can send Sigurd a proper web form, and now I should be able to get the data coming back. He's answering. When he actually opened, the browser opened two connections. The one was idle, you saw there was like an empty one, but now it started sending traffic, so it's kind of eager, opening two connections to be ready. Now his posting name, okay, wants to talk to me, okay, document, blah, blah, blah. So what I'll do is I can say, I know his name now. I can sort of reply. Oh, no, sorry. Yeah, he posted his name back, so I can. Where did I? Yeah, I'm gonna use this now. So he said his name was Sigurd down here. It's actually also it's in the body of the post request, a bit hard to read here. So I have this HTTP template with this syntax, what you call it, like a placeholder thing. It's like almost like mustache. So I can just fill in his name, and I can say hi Sigurd, and I can set a cookie with his name in it. Then I can send this response back, and then Sigurd get this nice response back and a cookie set and a link where you can click for more data.
Yeah. So this cookie that we have here is just a because HTTP is stateless. We send in documents back and forth, and we do not have a thing about state really. So when I send my name to the server responds with, "Oh, that's cool. That's your name. I'm sending you a document back, which says set cookie." And it's the browser's job to remember that cookie and include it in every document it's sending to this server afterward. So now when I reply, when I want to see my personal stuff on the server,
yeah,
I'm sending that cookie back.
So now he did a request to this personalization URL that he clicked, and I can see here, oh, cookie, this is Sigurd. Ah, okay, so I know who this is, and he wants some personalized information. Then I can go and look up in my database. Okay, what does Sigurd like? Executed. Sigurd likes cats. Okay, cool. I have a new template, Sigurd, and I know he likes cats. So I can do placekitten.com 400 and I can send him this request back.
Thank you. I like cats.
And this is why the internet was built, and this is how the web works, right? This is how the web works. There's really not a lot more to the web than this, in my opinion. This is hypermedia, it has images, it has links, it has forms, so I can ask him stuff, I can talk to him. No API contracts, no out of bound anything. Beautiful,
no
simple.
JavaScript in this case.
Yeah. Oh, you want JavaScript? Script window location equals tvnrk.no since we're here. I'll send you some JavaScript. So and it's really cool with the new browsers. They just stream stuff and process stuff as it comes along. It really shows like how dynamic the web really is and has become with these modern browsers. So that was the web and the internet, I guess, in 20 minutes. So that was sort of the reason for this hobby project, was to be able to have a playground where you can work with these sort of things at this level where you have HTTPS. And it works like properly on the internet as well. Like I have this, oh, come on. Pokemon. I think I'm able to do it. No? And so it works on the internet as well. So if someone has a phone, I want to go to byhand.bjartnes.dev on their browser. Feel free. So it's Bjartnes byhand.bjartnes.dev. Then it should work. So it's web scale. Yeah, so someone's coming in here, and and I can do like HTTP 11200 OK, and I can go to this guy. Oh, come on. HTTP 11429 retry after. What is the header for retry after? Is something like wait until after the meetup. And it gets kind of busy. But it works fairly well. I was thinking if I was gonna do something like this at a conference, you can reply to someone, the person gets a reply, gets can put their hand up, and we'll throw goodie bags to them and so on. But it's all web scale, and yeah. I don't know where we're at the time right now. I could mention a few things about like the just internals of it. It's an open source project. It started out by having this terminal kind of user interface, which is like in here, which is using terminal GUI, which is a really cool project. But I'm not a front-end developer, and the code got fairly messy. Then at the previous meetup, Harald Ulriksen demonstrated a kind of Elmish thing with a similar kind of terminal tool, but a different one. And I found one for this. But made it sort of work. But there were some bugs in that framework. Then I just posted on Twitter, and I got some feedback on from Atle on that there is this Avalonia functional user interface, which was also using the Elmish kind of architecture, which even I, who don't do a lot of front end, can understand and work with, because it's very functional and fairly straightforward. So that's when I sort of switched to this Avalonia thing. And Avalonia is I don't know, like VPF, only it works. It's an open source project, and it works on Mac and Linux and Windows, and it has this functional wrappers, which is really nice, because I was like, most of this is a hobby project, so I'm like sometimes sober, sometimes not when I write the code. So the next day, it expands into a lot of different things, and the views really grow. But then I was like, okay, so how do I refactor this into a subview? And like in SAML, I'm like, okay, then I need to buy a book or something. Like, how do you make components? But in here is like the F# joke, like everything is just a function. So you just pull out a function. Like it's so easy to work with these user interfaces, because they're all just basically a function that takes some model, renders a view, and has a dispatch function that can run some command when you click it. So that was really nice, that it's really a functional UI that works on Windows and Linux. And as you see, you can like even debug it on in VSL. So from Visual Studio, it runs on Linux, but the debugger attaches properly. The UI shows up in Windows. Like, what's not to like? The other part is that TCP is not functional at all. Like, it's streaming and buffers, and there is no way around that. But F# has these nice mailboxes. Same thing we saw Vincent was using, showing the server sent events. And this can really wrap up each of these things. So there's one process that is listening for connection. That's one mailbox, and that spits out connections. That's a mailbox per connection. So you can sort of contain with F# the kind of hairy parts of this. Set breakpoint in line, it says in my documentation, but it doesn't say where, in which part of the code. But I think it's like in probably something like in the connection controller. This is where you accept connections. So if oh, there was a connection. No, it's probably none. If there's some connection. So basically you can you wrap all this hairy kind of system IO accept clients and so on in mailbox processors, and it's good to go. So I would say like F# has really driven me into what I would call pit of success. You just use the F# things, and I didn't do a lot of upfront thinking. It was more like by applying this functional UI and using the mailbox processors, things sort of just, I don't know, made sense. I don't think we're going to go into the details of the implementation. It's not very interesting. It's, as I said, I'm half sober when I write this code, but it's on GitHub if you want to play with it. Any questions? Except why?
Why?
It's on. I have this workshop, which is like an HTTP workshop that doesn't really use this chatbot at all. It's just like pure HTTP, the netcat, all of that stuff is on GitHub. So that's documented. If someone wants to play with it, it should be possible to run without a lot of work. Has also like Nginx stuff and how you do HTTP proxies in between and all of that stuff. And then I have the HTTP chatbot code is also here. It almost built on your machine, like, or
It ran on my machine.
Yeah.
It worked.
So it works. It's tested on another machine, so you can try it if you want to play with it. But if you want to play with it and you get any issues, just like feel free to shout out and we can have a look. Any questions? No. Cool. Yeah. Oh, that's actually a good question. So I've been reading up on HTTP 2 and HTTP 3. And like, I think the answer is likely never. That's my, because the main reason for doing this is sort of to understand the semantics of the protocol. And once, like, I find that once you understand this, the TCP stuff, the messages back and forth, the semantics, understanding that HTTP 2 is mostly like, okay, so we want to run everything over one connection. So we have some multiplexing of the frames, and then you get the binary format, but it's the same semantics. And then HTTP 3 is basically just that, okay, so we have some blocking on TCP because everything had to come in order. Okay, so they want to get around that. So they build something on UDP where you can do like the connection stuff in userland on top of it. But that's more or less it. And I was like, am I going to do the implementations because they're much harder, just to learn that? And I think likely not, likely never. No, yeah, but likely never. But it's I've been asking myself those questions many times, and I would likely probably dig into that a little bit, maybe. But I don't think I'll ever write it. I don't think so. But I would argue that I really struggled understanding HTTP 2 and HTTP 3 properly before I grasped HTTP 1.1. But like, I'm not sure you need to understand HTTP 2 and 3. Like the syntax of those protocols. And it's possible to understand the connection handling once you understand this, is my kind of point of view. But it's really hard to understand the connection handling or the reason why they did HTTP and HTTP 3 if you don't understand the basics of HTTP 1, because it's all like trying to fix shortcomings of HTTP 1.1. Yeah, that's like the serious answer to it. But I'm for sure gonna play with it. I'm gonna try at some point.